Hello, everybody. Thank you for joining the Startup School for Google for Startups. Today, we're going to be talking about, we're going to take a deeper dive into the Vertex AI for machine learning practitioners. My name is Tristan Lee. I'm a principal architect here at Google Cloud. And along with me is Mona, and I'll give her a chance to introduce herself as well.
Hi everyone, I'm Mona and I'm joined with Tristan today in the session Vertex AI for ML practitioners. I'm a AI ML customer engineer in Google Cloud and I'm also an author of a book called Natural Language Processing using AWS AI Services. I'm really excited to talk about generative AI on Google Cloud.
So today's agenda, we're going to take a look at Google Cloud AI overview. So just to give you a real quick high-level overview as to how Google and Google Cloud provides the AI services and our approach to machine learning. And then after that, we'll take a look at Vertex AI. We'll give you a quick overview of what Vertex AI is about. You might have heard this from other sessions, but we're going to dive a little bit deeper into the Vertex AI, into the different features that it offers within Vertex AI. And then we're also going to give a real quick overview on generative AI as well. My good friend Mona is actually going to be leading that, show you some of the capabilities that's already built in with the Google Cloud Vertex AI for generative AI. And then we'll go through some of the demos. Mona's going to go through some of the really cool demo that she has built for you, and kind of drive home the point, some of the stuff that we're going to be talking about today. So if we look at the our approach to artificial intelligence, Google as a whole, we have over 10 platforms that has over 1 billion users globally. And we apply machine learning to all of these platforms, right? So if you go into Gmail, for example, you'll be able to actually has the auto completions and those type of things. Those are all driven behind the scenes by artificial intelligence. So what does that mean? What this means is that we are actually leveraging the expertise that we have in these large scale platforms and bring that over to Google Cloud and offer it to the enterprise customers or the customers such as yourself, right? So our mission in Google Cloud is to democratize artificial intelligence by making it easy, fast, and useful for all developers and users. So we don't really want it to, data scientists, they're very hard to come by. They're they're also very expensive too. But we wanted to make sure that we be able to actually democratize this so that everyone will be able to take advantage of it, but also make it easy and fast and useful, right? So as you will see later on in the session today, I hope I'll be able to demonstrate that by leveraging Vertex AI, it will save a lot of time, and also the different offerings that we have within Vertex AI that would be able to help not just the data scientists, but also for developers and users as well. So if you look at the typical machine learning lifecycle, you see that first thing we do, right, is we got to find a problem. So we got to define a business use case. So it might be a fraud detection, right, use case. So that would be, it could be a binary classification, depending on how you wanted to be able to approach this fraud detection. It could be a anomaly detection, right? So there are many ways to approach a business use case. So that's why you need to be able to have a platform, have a tool that will be able to do the data explorations, right? You might be doing some histograms, you might be doing some scatter plots, just to kind of look at the distribution of certain data sets. And then also to be able to pick a different algorithm, right? For example, for fraud detections, it might be a binary classification. So you might be picking something that's XGBoost or something like that, right? That'd be able to a tree-based algorithm to be able to do the binary classifications and whether it's a fraud or not. Or maybe you might be using some unsupervised learning, such as, K-means cluster to be able to actually do anomaly detections to detect whether it's a fraud or not, right? So all of those things, you're going back and forth. Your data scientist team's actually going to be spending a lot of time in this, where you're going to look at the data that you have. You don't want to have garbage in and garbage out, right? So look at the data. It's very critical to be able to actually do the feature engineering, right? In step 4, building that data pipeline, automating that, and then just continue to iterate through that, selecting different algorithm. Maybe you'll be doing some of the hyperparameter tunings in between, right? To actually to build the model that actually with the right parameter, with the right algorithm, with the data set that you have engineered, and then be able to feed that into and then build that machine learning model that you want, right? And then you will evaluate it and see how it's actually performing and presenting that result, right, back to take a look at it and see if it actually is is performing, right, based on the errors and things like that. It's actually doing what is needed, what you need. And once that is actually performing the way that you want, you plan that for deployment. So you got to start thinking about, okay, what would the hosting environment would be, right? Is the use case going to be a more of a batch prediction, or is it online inference, or maybe both? How do I actually be able to host that model to be able to use it for multiple purposes, right? Maybe it's an online prediction or batch inference, right? So you got to plan that, have an environment hosting that model, and then also have that data pipeline that you might be doing, that you did for your data during your data prep and data exploration. And then you operationalize that model, deploy into your production environment, right? Then once that model is in the production environment, it's not completely done yet, right? It's not just set and done and forget it, right? Because your data over time might change, right? Your distributions of your data, the model might starting to drift, right? Because the data distribution changes as the time over time. Your customers' data behavior might be different than the time that you actually train that model. So you want to be able to have a capability to monitor that model, right? So we'll talk about each one of these steps, how Vertex AI will be able to easily and help you to be able to perform all of these things that we just talked about here. Okay, so with Vertex AI, we wanted to be able to build a unified machine learning platform to solve all business problems and for everyone, right? As we mentioned before, we want to democratize AI for all of the developers and users and data scientists that's out there. And we want to be able to solve all of the business problem that is the machine learning business problem, right? So if you look at the right-hand side here, what we did is that we want to have a layered approach. And you'll see this as you see with Mona as well. When she show you the generative AI capabilities, you'll see that we have that layer approach as well. So what it does is that at the first layer, right, we wanted to provide that low code, no code workflow to everybody. So that what that means is that you don't actually have to actually be a data scientist, right? You can just bring your data sets to Vertex AI, and you'll be able to train a model leveraging the algorithm and the platform that AutoML offers, right? And same thing with the BigQuery ML. What it does is that the AutoML piece, it does a lot of things behind the scenes for you. So, for example, it does some of the feature engineering, such as imputations for missing values and things like that, like one-hot encoding for categorical data. All of those things that I mentioned about in step 4, right? You're doing the feature engineering. It's actually doing some of those things for you behind the scenes. So you can bring just that data over and then pick the use case that you wanted to do, whether it's a tabular data for or maybe it could be a forecast data set that you wanted to do for time series, right? Or it could be a computer vision or language, anything that depending on use case, you bring that data set to Vertex AI, and you'll be able to train a model leveraging the AutoML. And a lot of data scientist team actually really like this capability as well, because one, they can use this as a baseline for them to compare with the custom models that they might be building themselves. And second, it's just much faster. It's easier. You don't have to write a whole lot of code. It's almost no code. All you got to do is bring your data, and then you train a model. You come back and evaluate the model, see how it performs. And then the other data scientist team also do is that they leverage AutoML to build a baseline. to compare to their custom model, right? And see which one performs better. Whoever performs better, they will leverage that. I'm not going to touch too much about the generative AI app builder and generative AI capabilities, as Mona is going to be showing you how that actually works later on. And then, if you look at the work from the data scientist toolkit perspective, the toolings and things like that, we want to provide you the workbench. So that workbench is going to be the Jupyter notebook. We'll have different flavors of them for different purposes. And basically has all of the libraries that are installed, and it's the latest, right? So, any of the DNN libraries, and we support PyTorch, we support R, we support Spark, we support TensorFlow, scikit-learn. All of the different kernels are already installed in there for you, so you don't actually have to worry about configuring those different kernels running in different environments. We pre-build those things for you so that you can just hit the ground running very quickly. You can start experimenting with your code, right? And then we have other integrations with the data services like Google Cloud Storage, BigQuery. You'll be able to actually leverage the workbench to reach out to BigQuery to grab the data and to do your data explorations, right? Spark as well, and also the other databases such as Spanner and things. And then at the custom workflow level, you go one layer deeper, where we provide the data scientist teams and practitioners more capabilities. This is where you actually be able to do custom training, right? Do hyperparameter tunings. You'll be able to actually do the predictions as to how you actually be able to host that into a different endpoint, which we'll talk about a little bit later as the deployment. And then be able to compare the different you can evaluate a model, compare different custom training jobs, how they perform differently, and then also have metadata that be able to tie to each different training job, so that you actually have the lineage of all the data inputs and outputs that you have together. And then at the very bottom, obviously, is the ML ops. This has been becoming very popular because obviously you saw in the earlier slide, there's a lot of steps involved, right? It's a very time consuming. You wanted to be able to actually automate that, so that you will actually be able to build an automated pipeline to do the training, right? To the processing, to training, to do maybe hyperparameter tuning, and then to serving, to deployment, and then do the monitoring too. You want to be able to monitor your model in production, so that should your data change over time, your distributions for your data and things like that, you want to be able to capture that and maybe re-trigger this pipeline to retrain the model that you have at that time, right? As I mentioned with AutoMLs, right, with the pre-trained models, the way we wanted to approach with AutoML in Vertex AI is that we want to be able to address maybe 80 to 90% of most use cases out there. So it's not just for tabular data, as you can see here. We can actually, you can train machine learning models for computer vision, right? Such as object detections, classifications, right? Image classification, the typical image classification use cases. And then also from a language perspective, we have very high level, NLPs, natural language processing. You can do entity extraction, sentiment analysis right off the bat with Vertex AI AutoML. Now, this is obviously before the large language model, generative AI things that came out. So Mona actually will be able to cover a little bit more as to some of the more language capabilities that you can leverage through large language model. And then the conversational things such as speech to text, text to speech, those type of things as well. Those are all built in within the pre-trained models. One of the really cool things that I wanted to talk about is it's a neural architecture search, or NAS. It basically is a technique for designing the neural network. It is very interesting. This is not a typical hyperparameter tuning. This is actually a architecture. It's building a natural neural network, right, on the fly for you. So, for example, some of the architecture parameters can be kernel sizes, number of connections that you want, and any other type of combinations through a search space. So these things are actually being employed, these architectures and algorithms through the search space. It's actually been built behind the scenes for you in AutoML. And this is part of the reason why our AutoML offerings are very, very accurate, right? It's a little bit more accurate than the other offerings on the markets, because that we're able to not only doing the hyperparameter tunings, but also be able to build a network behind the scenes for you for that use case with that data set that you provide. And then I kind of mentioned about the workbench already. The workbench obviously is fully managed with all of the tools that's installed. So if you're using Jupyter Notebook, as you can see in the screenshots here, we support PyTorch, we support R, even we have customers actually using R on the platform, TensorFlow, scikit-learn, all of the libraries that you need to actually be able to do your data exploration, to do your data science things are all, the base libraries are pretty much all loaded in there. And you can easily install additional libraries that if you want, right? And then you can build workflows leveraging the different type of notebooks. They can actually execute on a scheduled time. So there's a lot of capability that's built in with Workbench, not only just providing that Jupyter Notebook experience to all the users. And when you look at the training, we have custom training techniques, right? So features that you'll be able to use. We have a training pipeline that you'll be able to build out your custom trainings. In Vertex AI, everything is container-based. Okay, so it runs on all of the if you look at the typical trainings and the servings, as well as the even some of the workbenches, you see that they're all container-based. So they're running on a container. What does that give us? That gives us the flexibility, obviously, right? So what is going to happen is that for example, in the training, you can actually bring your TensorFlow. We have built-in containers, right, for TensorFlow, PyTorch, and scikit-learn, and those type of things. What you could do is that you can actually just bring your own script, right? What we call bring your script. You can actually be able to just leverage the containers that we provide to you. And you can bring your Python script into that, and you'll be able to train it within that container. You don't have to install anything. It's all pre-installed for you, right? With all the libraries that you need. Or you can also bring your own containers, your Docker containers. Right, we support that as well. So in there, then you can do anything you want, right? Currently, we support PyTorch, TensorFlow, and scikit-learn, and those type of things. We have seen customers bring their own, R containers that be able to actually train the model leveraging R. So you can do that very, very easily yourself as well. And one of the things that I kind of mentioned already, the hyperparameter optimization or HPO, or hyperparameter tuning, is that there is a built-in hyperparameter tuning stuff for AutoML, but also you can leverage it out of the box as a feature that you can actually train with your custom trainings, right? So a lot of the things are already built in, random search, and Vizier is the actual HPO technique that we use. So you'll be able to actually leverage the different by default, the Vizier actually leverages like Gaussian process bandits, linear combination search, or some other variants to find the best way to actually to find that the most optimal parameters for your model, right? So these things are all built in within Vertex AI that you'll be able to leverage. And one of the other thing I forgot to mention is that everything that you're showing so far, Workbench, HPO here, and also custom trainings, all of them are modular. So what that means is that you don't have to actually use end-to-end all of the features that I mentioned about here today. You can pick and choose. We have customers actually train the model on leveraging HPO on Vertex AI, and then they take the model, host it elsewhere, or we have customers actually bring up their models hosted on Vertex AI as well. So we make it very, very robust and make it very, very modular so that you don't actually have to do from start to finish, because we want to meet our customers right where they're at. So we talked about training, right? We talked about data explorations and things with Jupyter Notebook. We talked about custom trainings. We talked about hyperparameter tuning. And now it's time, once you have that model built, right? If you remember that the life cycle that I mentioned about earlier, now it's time for prediction. So we have Vertex AI has the capability where you can actually host your own model, or you can use the model that's actually trained within Vertex AI. So for example, AutoML I mentioned before, you can actually deploy that into Vertex AI prediction or endpoint for prediction. So Vertex AI supports both batch inference as well as online prediction. Okay. So the online prediction is where you're actually going to deploy a container into the endpoint so that it will actually be able to load the model up and then be able to serve that to online real-time inferences. And you can also do batch prediction. What it typical use case is actually for, if you have a batch-oriented type of workload and you have hundreds of thousands of inferences that you can do at, during off hours or something like that, you'll be able to do that as well. And the good part is that once you train this model once, this model can be served to both the real-time endpoint, and also the batch inference as well. So it's the same code, it is the same model, it is the same container. You don't have to change anything. And another thing that's really big in the AI field also is the explainable AI, right? A lot of times that customers or people wanted to be able to explain the decisions that what is more important, like feature attributions, feature importance, between different models that you build, right? So, for example, in a regulated industry, they may want to, like insurance and things, right? They may want you to be able to explain, to say, hey, this model that you build, so there's no bias. How did you actually arrive this? The model arrived this prediction, right? So if you look at we provide that capability within Vertex AI as well for images and tabulars and text and things like that, where it can, at the model level, when you're training it, you'll be able to actually see the feature importance of each different features that you have in the data sets that would represent which one takes the most of the importance during for this model, right? And then at the inference point, you'll be able to actually see the feature attribution as well at that one individual prediction. So, for example, when you're doing a prediction for a certain set of data, right, one row of data, one record, you'll be actually the Vertex AI has the capability to actually explain to you, okay, for this prediction, for this specific data set that you've given me, these are the things that we are influencing that prediction. These, the attributions of different features within that prediction. So very, very robust, as you see here, that you'll be able to both at the model level, but also at the prediction level. So in addition to all of the other things that I have talked about so far today, Vertex AI also bring to the table to data practitioners and data scientists the other things that you definitely need, right, in your machine learning journey, but also it's kind of arduous to actually maintaining these things. So, for example, feature store, right? A lot of data scientist teams and data practitioner teams, they would like to share the features that they engineered, and they want to be able to share that and also be able to use it for training and also use it for serving. So they want to have a snapshot of these features for different things. And it typically takes a lot to actually build, maintaining it and then building a feature store. So what we are doing is that we are offering a managed feature store, right? It's completely serverless. You don't have to worry about the infrastructure. You don't have to worry about the databases that's actually hosting your data, right? Storing your data behind the scenes. It's just an API. You just store your feature store, features in your feature store, right? And you'll be able to pull that out. You can share this with your fellow data practitioners, and you don't have to worry about the scale. right? Or the latency. It's all managed automatically behind the scenes. And then along that line, we also have metadata. So, I kind of mentioned about it earlier, where you want to be able to actually, during the different your training jobs, you want to be able to go back to it and say, hey, for this training job, why is the accuracy is a little bit better than the other training job? What data set did it use, right? The inputs of it, and what parameters did it use? What was the output of it? The metadata tracks all of those stuff for you, right? Again, you don't have to build a database. You don't have to worry about the scale. You don't have to worry about the latency. That's all managed by us. It's completely managed, right? You can just leverage it like an API, just like Feature Store, and it will be able to, all you have to focus on is to be able to actually look at it, compare it later, and have something that's be able to store all of the artifacts for you, which that's what the Metastore does. And then the model registry is basically to keep track of different versions. You can organize it different ways and track and register these machine learning models within Vertex AI. Okay. So what it does, for example, the AutoML, when you train a model, it actually will automatically save that into the model registry. You can import models, right? And then you can import those models and host it on the Vertex AI endpoints for real-time inference or for batch inference. You can also export this model in the model registry as well. So once you have the model registry, you have the capability to be able to evaluate the different models that I kind of mentioned about, right? And you want to be able to identify the best model for production deployment. So that's where you can be able to actually evaluate the different models, how they're performing, what data sets that have been used in the metadata, right? And then you'll be able to actually evaluate and decide which one that you wanted to be able to deploy to the production environment. And then finally, the model monitoring, right? I kind of mentioned about that many times already. You want to be able to, once it's deployed into production, you want to be able to have a way to actually monitor that, because over time, data can change, right? How do you actually be able to automatically get alerted, monitor it, and then get alerted if something is changed, right? Like any type of distribution in data that is skewed or that has been drifted over time. That is different, right? And then you can trigger something to do to automatically train that model once again, right? And that is what the ML Ops is about. So we have a managed service called Vertex AI Pipeline, and that's built on top of Kubeflow, basically. So you see KFPs, basically Kubeflow processing pipelines. And we support TFX as well, the TensorFlow extensions. So what it does is actually you'll be able to actually orchestrate the entire thing that I mentioned about, right? From step 3, from this life cycle to all the way to the end to monitoring. So tied all together, what's going to happen is that you'll be able to actually grab the data, right? Train the model on the data that you selected, do the pre-processings and all of those things, and then you'll be able to do hyperparameter tuning in between if you like, right? And then evaluate the model, and then save that into model registry, deploy it to either Vertex AI endpoint or for batch prediction, and then you can also eventually do the monitoring on that. So when the monitoring comes in to say, hey, your data has changed, right, to a certain threshold that it needs to be retrained, it will trigger the pipeline again. So that's how it actually works overall. And with that said, I hope you find that informative. I'm gonna go ahead and turn it over to Mona, and she will go ahead and take over and show you some of the generative AI capabilities on Google Cloud, as well as in Vertex AI, and also doing some of the, do some really cool demo to show you some of the things that we covered today. And with that, I'll turn it over to Mona.
Thank you so much, Tristan, on covering the Vertex AI platform, which is an end to end platform for data scientists to start with building their models, tuning their models, and deploying their models. Today, I'm going to talk about what is possible with generative AI on Google Cloud. The revolution started at Google and we continue to innovate. In 2017, Google invented the transformer architecture that powers the large language models in 2017. So you can see from the timeline that we have been doing generative AI and large language model from a very long time, and we were the first in AI frontier to bring transformer architecture and large language models starting from 2017 onwards to 2023. And you'll be surprised to know that large language models already power our cloud AI products, including contact center AI, document AI, the content classification, as well as the most popular Google search. Lastly, we are pioneers of research in AI development. 3,000 plus Google plus DeepMind researchers and 700 plus scientific publications continue to drive our research to product pipeline. So, whatever you see in Google Cloud is directly derived from Google's research, and we are making sure that we are bringing the products from research in less than 2 years to you so that you can consume the latest AI technologies with Google Cloud. You might have heard about the launches this year in February regarding BART as well as Vertex AI enterprise offerings. So, wanted to differentiate because customers always ask questions. We want to use Bard, and when should we use Vertex AI? That's a very good question. And in order to highlight what is different here is consumer and enthusiast, they need an easy prototyping tool, which is our Bard plus Macro Maker. So if you want to try Bard, go to bard.google.com and get started. And if you just want to prototype something with the APIs we released earlier this year in generative AI, you can do so using Macro Maker. However, consumer and enterprises has different needs. So with enterprise, a lot of things changes. Like it is really Bard is really good to prototype something and get started quickly. But if you have enterprise needs, like you need regulation, you care about security, you care about explainability, and you also care about building an end-to-end solution which is scalable and highly available. This is where the Vertex AI enterprise generative AI offerings comes into picture. And this is where you should focus on if you are building applications for enterprises. Expanding our portfolio to support the needs of generative AI centric enterprise development. And this is where we have added generative AI into the Vertex AI platform, which is a platform which Tristan covered in details, which gives you ability to train your model, tune your model, and it has all the infrastructure needed to make you scalable, highly available in the cloud. So let's take a look how is the generative AI centric portfolio looks like with Vertex AI. Starting from the bottom, we have end-to-end machine learning platform of Vertex AI supporting our generative AI studio, which is a prototyping interface for some of the large language models. Then we have Model Garden, where a AI practitioner can come in, choose third-party models or open source model or our Palm APIs, our models, and get started quickly with Vertex AI and generative AI. And for developers, we created Generative AI App Builder, which is again a no code, low code offering for some of the use cases, very common industry use cases, such as creating a enterprise level search, which is similar to Google search, as well as conversation. On the top, for the business users, our contact center AI, document AI, discovery AI, and healthcare AI is already powered by large language models. So you get the benefit of all the Google's research from our top to bottom stack of Vertex AI. Now talking about generative AI Studio. What is generative AI Studio and what does it offer? So it offers four things out of the box. It comes with a very simple UI for interacting with models. It's so that you can get started very quickly. It is easy to prototype. The second thing, it gives you ability to tune your models with your own data. So with generative AI, you would always want to customize things based on your need, because these models are trained generally on the data source. But for your use case, you want to customize it, then you will use the second thing, which is tuning. The third thing is you can use these models in production. So once you have tuned your own model based on your use case, you can do one click deployment using Vertex AI, powered by Vertex AI predictions. And you can deploy these models in production and use these models for inferencing. Lastly, it supports multiple modalities. So you don't have to just worry about the text modality. Generative AI Studio supports language, uh, vision, as well as speech. So they have multiple modalities you can try and come and play with. We'll see that in the demo today. Moving on to Vertex AI Model Garden. What is Model Garden? It is kind of a one-stop shop where you will come, look into your use case, whether you're looking for a image use case or you have a language use case. You can search based on your use case and it will give you a suggested model. So you can find the models, and Model Garden has open source models like BERT T5. It also have third party models if you want to try. Also, it has Palm APIs, which we released this year, the Google's generative AI model. So you want to try any of these models, you should. This is the place where you will come and get started. Second, it comes with tuning foundation models. So, Model Garden is kind of a one stop shop interface where it will take you to, if you click on any model for generative AI, Palm APIs, or it will take you to Generative AI Studio directly, where you can go and tune the foundation models. And if you're using open source model, it will create a notebook for you or a deployment for you based on the use case you're looking, and then you can tune your models. Lastly, you can customize popular open source models like T5 Flan, which is like a very, very nice way to get started with open source large language models. And fifth is it has API specific, task specific solutions. So suppose you don't want to spend a lot of time in coding, you are looking for no code, low code API level solutions, you can come to Model Garden and look for just API access, task specific solutions such as classification, sentiment analysis, content moderation. All of this is supported in Model Garden. Talking about foundation models, what are foundation models and what we offer today through Generative AI Studio. So these foundation models you see is available through Generative AI Studio for you to try and prototype and get started quickly with generative AI. The first is Palm for text, which is very, very customized for language specific tasks. The second is Palm for chat, which supports multi-turn conversations with session context. Third is Imagine for text to image. So this foundation model APIs will help you create and edit images from simple prompts. We also have launched embeddings API for text and images both. And so what will this API help you is they will help you extract semantic information from unstructured data. So suppose you have large structured text such as PDFs and documents, and you want to create embeddings. So previously, how users will create embeddings is they will have probably they will use a machine learning model which will run on an infrastructure. So they need an infrastructure to support that model, and then they will put a lot of data and run the training, and that will create embeddings for them. But using embeddings API, it becomes very, very easy because you are not worried about create having a model and then training that model on an infrastructure. So you're just using an API, you pass input as the PDF documents, and you get embeddings out of the box as an output. It becomes simpler. So you can use this embeddings API for text and images. Moving on to speech side, we launched Chirp, which is ULM model for speech to text. It helps you build voice enabled application. And what is unique in Chirp is that It can be used with um, speech to text translation with multiple languages, because it has been trained on multiple type of languages as well as dialects. Lastly, code generation is very, very common use cases with generative AI. So we have a foundation model or API called Cody for code generation, which can improve your coding and debugging capabilities. Talking about search, we all like Google search and we all want to create enterprise level search like Google search experience. We all want to find information faster. With enterprise search, it becomes very, very easy and possible. And how it is easy and possible? Because first, it's an out of the box search experience. So you don't have to worry about setting up an infrastructure to creating a Google like search. We are providing you an enterprise search with out of the box experience where you just provide your data sources, and with one click, it is everything is searchable and everything is indexed. So that is a very, very easy and powerful way to get started with search. Second thing, you would like to know, can I customize this search? I know it is out of the box, but every organization and every customer has a different need. If I'm a healthcare customer, I'll have a different need versus a public sector customer who have different needs. So this search has this tunable capabilities where you can tune this out of the box. And lastly, you can also build your own search with advanced machine learning tools. So this is the complete end-to-end search solution. Talking about reinforcement learning from human feedback and why it is important. So what is reinforcement learning from human feedback is that you can improve model performance by making it more adaptable to user needs by having a user feedback. So, in case you all have seen Bard or played around with Bard, you might have seen a button called thumbs up, thumbs down. So, that is the way you are providing feedback to the system, and that is making the models better. And that is the concept behind reinforcement learning from human feedback. So, some of the ways that it can help, especially when you have edge use cases where you cannot change the model size, because large language models are huge, they're trained on billions of millions of parameters, and they need a lot of compute and infrastructure to host these models, even to deploy these models. But you don't want a bigger model. On edge, you have limitations of capacity. How you can use reinforcement learning from human feedback, that it improves the pre-trained large language model without increasing the model size, which is very, very effective in getting you the accuracy you need even with a smaller large language open source model. So this is the way you can have full control with a human in the loop, with a large language model or a generative AI model or the APIs, and you can make sure it is getting better based on your needs. Lastly, I wanted to cover that how you can think, like we covered Vertex AI platform in details. We covered the training jobs and we covered the model registry, the prediction, how it maps to the generative AI capabilities, right? How it maps when you start with prototyping first. The first step in any generative AI use case is prototyping, seeing if the technology is feasible for my use case. This is where the Vertex Generative AI Studio, you'll go to Vertex Generative AI Studio and start playing with it. When you want to develop something, now you are happy with the prototype, or let's go in production. Then you need SDKs and APIs, and Vertex SDKs is the place where you will go and find these APIs and SDKs to build the prototype into production ready application. For tuning, you will go to Vertex training jobs. So a lot of these tuning task is run on Vertex training jobs under the hood. So you can go to training and find the tuning jobs. And this is where the power of Vertex AI infrastructure comes into place for training. Lastly, where you will find the tune models. Your model has been tuned. You want to deploy them, right? You will go to Vertex model registry to find your all the tune models, and then from there you can deploy the model on a Vertex prediction for serving. Lastly, we all want everything to be orchestrated. All the steps needs to be orchestrated when you are building a pipeline or when you are thinking of automating everything. Then this is where the Vertex pipeline components come into picture, and it will help you with prompt validation, evaluation, and reinforcement learning with human feedback. With this, I would like to take you to a demo of Generative AI Studio and also the Vertex AI capabilities we covered today, like training, tuning, prediction in the console. And the third thing I would like to show in the end is how tuning works and how it creates a Vertex AI pipeline with tuning. This is the Google Cloud Console for those who are coming here for the first time. How to get to this? You need to sign up to get a Google Cloud Console. Talking about Vertex AI, I just like using the search bar and search for Vertex AI. I'm in my Vertex AI console now. Giving you an overview on the left hand side, you see is all the services which Tristan and I covered today. We'll give you an overview what we have, everything in Vertex AI, and then we'll deep dive a little more into generative AI side of things and give you an overview of Studio as well as Model Garden. And if time permits, we might cover tuning for you. So on left hand side, you see a dashboard, which is this dashboard. It has the notebooks, Model Garden, Generative AI Studio, some recent data sets, notebooks, errors, and models. This is your starting point. And then you have Model Garden. Workbench is a place where you can come and create managed notebooks as well as user managed notebooks, uh, which is nothing like a managed Jupyter interface to come and get started with your actual code. And we'll see one of the notebooks in action. We have Generative AI Studio. I'll go there after I cover everything. So starting from your data, if you are creating a model, you'll come to the data section and create a data set. I have already existing data set for text, image, tabular. You need to come here and get started. So first step is create a data set. And then once you have created a data set, suppose I have created a tabular data set, and then I can come to training in model development and create a training job. You can see that I have a lot of training jobs. Some is classification, some is image detection. And when it says custom, what does custom training means is you are bringing your custom container with the code and creating a training. In order to create a training, it's very simple. Click on this create button. You can choose the data set in the first step. And you also have choice to choose no managed data set. So what is a no managed data set is different than a managed data set. No managed data set is suppose you have a data sitting in a cloud storage bucket. You can directly point to that and not create a data set in Vertex AI. So let's go with a data set, and then you have choice in training whether you want to do AutoML or custom training. And what is custom training? You can run your TensorFlow, scikit-learn, XGBoost applications in the cloud with pre-built container or your custom container. So once you select one of the options, you can click continue. So I'm doing custom training, then it will ask you for container details, hyperparameter, which Tristan covered, and which compute you want to run this training. Google Cloud provides CPU, GPU, as well as TPU, which is very, very unique to Google. TPU is tensor processing units. So based on TensorFlow code you're running, you can choose TPUs. And you also have choice to have prediction here, but we're just doing training. I'll just do training. So this is how you will create a training. I'm canceling this because I've already trained a model here. Lastly, you have trained a model already. Now, how you will deploy and use. So some of the things which I want to show is model registry, which is the place you can do two things. You can create a model in model registry, or you can import a model. So suppose you have a model already trained on premise. Like in your laptop, you trained a model, but you want to use Google Cloud infrastructure to host that model. You can import that model into the model registry by clicking on that button and adding a name, description, settings, and with click import, it will be imported here. So I have imported this churn model for custom training on a GPU with TensorFlow. So this is how it's going to look like once it's imported. And any model which is trained on Vertex will automatically show up here. So this is the tune model from generative AI, which is showing up here. And it also gives the status of the model and the version and the type of model. So it's a large language model. And the source of the model, where what is the source. So it gives generative AI studio as the source for generative AI tune models. For AutoML, it will give AutoML source. Talking about predictions, Tristan did cover two ways you can perform predictions on Vertex AI online. So this is where you will come and create an online endpoint and use it in your applications. And this is where you can come and do batch predictions. So we covered end-to-end portfolio. We covered the data, we covered the model development and deployment and use. Moving on to generative AI Studio, and how it can help you with prototyping and multiple modalities. So talking about multiple modalities, it has language, speech, and vision. You can open one of the modalities. So let's try the language, which is the most popular one. And let's get started with the so three things I want to talk is we have the get started. If you just want to get started, you have choice to save a prompt and it will show up in my prompts. And third thing is you can do tuning here. So you can do tuning, you can come and create a tune model either from the UI or from the APIs. I wanted to show you how you can tune through APIs. And all your tuning jobs will be available here, whether you create it through APIs or you create it using the UI, which I'm showing here. Some of the prompt examples it already comes with. You don't have to worry about thinking about what to create a prompt. So it has chat prompts. You can start with any of the use case. Suppose customer service chatbot, a gluten-free chatbot, company chatbot. It has summarization prompts. So you can summarize an article, a call summary, a dialogue summary. Lastly, it has classification prompts, so you can perform sentiment, classify support help tickets, classify text, objects, headlines, articles, sentiment analysis. Lastly, with extraction, you can do a troubleshooting, you can do contract analysis, you can do text specs or question answering. With writing, generative AI is helping a lot. So you can do write a marketing announcement, you can write ad copies, you can create an essay outline, you can turn a paragraph into an email or a letter. And for ideation, it has a lot of ideas here. So let's get started and just try one of the prompts. So we covered a lot of foundation models today. Where you can come and find it in Generative AI Studio is once you open a prompt, this is where you'll find all the models. So for Palm 2, we have a text model. We covered code. So you can come and choose the code models from here. And the tune models also, you can find it here. So for this one, I have access to the text Bison latest model, which is at the latest. So you will see whenever we update our APIs or models, you will come and find the latest here and also the previous version to make sure your work is reproducible. We are going to use the latest model, and these are some parameters I want to cover. Temperature is how much control you want with the randomness in your responses. So high temperature means more random response, less temperature, less random response. Token limit, you can set what you want, maximum amount of text output from one prompt. And top K and top P are the probabilistic parameters you can set. And the safety filter threshold is a part of our responsible AI practices, where we are blocking, you have ability to block responses based on the filter threshold. And you can make sure that you have, if you don't want unsafe responses, you can choose the most. And if you just want, like if you want to go with the default, go with block few. And once you submit, you will have a generated summary here, beautiful summary about this very large text, which I didn't read. Two another things to call out is you have the choice to view code. It will automatically give you the code for your Python APIs. You can use it in any application. You also have choice to have curl commands. So if you are a Node.js developer, you can use curl commands to call these APIs. And also the collab is here. So you can try it in various modes. Lastly, you can save this prompt and use it in your prompt warehouse by adding a name. Going to tuning and how you can use some of the generative AI resources, we have created a GitHub repo where you can come and play around with these APIs and tools. This is the generative AI repo, and we will go to Workbench. I've already created a notebook. You will click on Open Jupyter Lab. And in the terminal, you can git clone the repo that will set up all the code and all the APIs available to you. We have a notebook called Getting Started with Tuning. In this generative AI language, we have arranged it by modalities. So in language folder, you will find all the text modalities examples, such as how to do prompt tuning, best practices, how to do tuning, which I'm here. And it also has summarization and some advanced reference architecture use cases. So this is the code how you will tune and deploy a model. So first is you will install the SDKs, and then you will authenticate your notebook. And then we are reading the data from BigQuery, which is our data warehouse, creating a cloud storage bucket, importing some libraries. And this is where the tuning happens. We are creating the data for tuning from BigQuery. We are taking the 10K examples from Data Stack Overflow, and we are doing the tuning with generative AI studio tuning capabilities. And once the tuning happens, you will have a model tuned. It uses TPU to tune the model, so make sure you have the right resources available and quotas available for TPUs. And then you can use the tuned models to get predictions here. In the UI, where you can find this tune model, you can go to Studio, Overview, and Language, Tuning. So this is the model tune model. You can come and find it here. And this tuning model automatically creates a Vertex AI pipeline under the hood for you. So it is here in model registry, and it also has a pipeline run. So it created an end-to-end pipeline for you from managed data set to prompting to TF record to a large language model up to a hosting and creating an endpoint. So we covered tuning workflow. I'll quickly show Model Garden. This is the one-stop shop to find any model based on modalities. Suppose I'm interested in a vision model and I want to do a open source model, which is one-click deployable. I can choose that, and I have two options available: Stable Diffusion and Stable Diffusion from Keras. So it gives the details and also gives a mechanism. If I click on deploy, it will help me deploy this model on using Vertex AI infrastructure. So this is how the model garden looks. We covered three things in the demo today. I showed you the Vertex AI interface on the left-hand side. Then I showed you Generative AI Studio. I showed you one of the language prompt tuning example, and then I showed you Model Garden. And most important, I showed you the Google Cloud GitHub repo for generative AI, where you can find all the developer tools you need to get started to build an end-to-end application. Thank you so much for your time today. We covered a lot, starting with Tristan's Vertex AI overview, and then I gave you generative AI overview, and I showed you a couple of demos. I really hope all of this helps you build unique, cool generative AI applications on Google Cloud.
All right. Wow. Thank you so much, Mona. Thank you, everybody, for tuning in. Really appreciate your time. I hope you find this session valuable. I had a lot of fun. I hope you did as well. Looking forward to things that you're going to build.